Let's take a look at this question. A lot of points of confusion on it. Was not intended to be so. I actually wrote the question so that it could kind of like break things into steps rather than requiring you guys to just, I don't know, leap into the darkness, but boy was I wrong. So part A asks us how much energy, or first off it asks, is the reaction endothermic or exothermic? How do we know? And when I read the question, it says calcium and nitric acid react. 0.75 grams of calcium react with excess nitric acid in 75 grams of water. The temperature of the water increases from 19.8 to 38.5. So, since the surrounding water to the reaction got warmer, all right, that means that the water gained energy, right? Its internal energy rose because of the reaction happening around it. So, as I reason, if the water is gaining energy, that surrounding area is increasing in energy, then the reaction must have been releasing energy that the water then picked up. So the reaction is putting energy outwards, and we would classify that as exothermic. Then B, it wants to know what is the energy change of the water during this process? All right, so to find the energy absorbed by the water, I know how energy absorption-y water is. That's called specific heat capacity, 4.18 joules per gram degree Celsius. And then that tells me to find joules, I also need to know grams and degrees Celsius. The temperature of the water, so the change in temperature for the water, it rose from 19.8 up to 38.5. So that is a positive increase of 18.7 degrees Celsius. How much water did we have? The mass of the water was 75.0 grams. And now I can find Q, because Q would be equal to S times M times delta T. 4.18 joules per gram degree Celsius times 75 grams times 18.7 degrees Celsius. Degrees Celsius cancels, grams cancels, we're left with just joules, and that's how energy is measured. And that comes out to be 5,860 positive joules. Then question C is how much energy was produced by the reaction? Well, and this was the big point of confusion, and I apologize for that. Where did the water get this 5,860 joules of energy? From the reaction happening and releasing 5,860 joules of energy. So the answer for C is just 5,860 joules of energy were produced when 0.75 grams of calcium reacted with excess nitric acid. Then in question D, we want to take calcium plus nitric acid yields calcium nitrate and hydrogen gas, and we want to add energy to the reactants or products appropriately. Since it was an exothermic reaction, I think that energy belongs on the product side because energy was produced. It came out of this reaction. I know, so I could just write energy. I would like the specific amount of energy that is associated with this balanced equation. So for every 1 mole of calcium, how much energy could we expect to get out of the reaction? We happen to know something right now. We know that for every 0.75 grams of calcium, we get 5,860 joules of energy out. And, that's the correct ratio, but not a very good number to report as like a standard unit of measure, right? We usually talk about how much energy might be made per mole of calcium, not per 0.75 gram sample of calcium. So we have a ratio, but it's not the most ideal ratio. So we need to find, basically, for question D, what is this ratio expressed as joules or kilojoules per mole of calcium. There's a lot of different ways that you could go about that. The very systematic approach would be, I want to know for 1 mole of calcium, how many joules or kilojoules. I happen to know this ratio, so weird as it might seem, I'm going to use this ratio as a conversion factor. So I would start with 1 mole of calcium times, now I want to use that ratio, but it doesn't give me moles of calcium, it gives me grams of calcium. So then I would say that for every 1 mole of calcium, that's 40.08 grams of calcium, times then it is, I need grams to cancel and get my energy, it is 5,860 joules of energy for every 0.75 grams of calcium. And then I would be left with, so let's see if everything cancels, moles of calcium, grams of calcium, leaves me with just a joules value. Are all of my conversion factors true? And that's the work that I saw a lot of students doing. They had conversion factors set up and the units canceled, but the conversion factors were not true. So is it 5,860 joules for every 0.75 grams of calcium? Yes, that is a true statement. Is it 40.08 grams of calcium for every 1 mole of calcium? Yes, that's true from the periodic table. And then all the units cancel, so all of my conversions are true, all of my units cancel. So basically, as long as I don't make a mistake punching it in a calculator, whatever answer I get here has to be true. And because of that 0.75 down there, I'm going to round my answer to 2 sig figs. So when I put this into a calculator, I get 310,000 joules. And just because it's the way they normally do it, and that's a really big number, I'm going to convert that to kilojoules before I put it in my equation. So I'm going to put it in as a product of 310 kilojoules of energy for every 1 mole of calcium and 2 moles of nitric acid. So then that is my final answer to part D.